Okay, we're going to find the equation of the exponential function that goes through P and Q, but not using algebra, using the transformations the way we discussed in class. Remember, the first step is just to draw the graph so we get an idea what's going on. 2.5, 4.7 is about there. This doesn't have to be great at this point. Q 7.4, 1.2 is way over here and further down. And I want to draw an exponential function through that. This is clearly a decaying exponential function, so I'm just going to draw something that looks like this. Again, it does not have to be fabulous. You can just be descriptive, which is what we have right there. Yay! Okay. Now the idea is, this is too hard. And so what we do is we make two changes to the graph until what's there is trivial, and then we work our way backwards. So this is what we're going to do first. We always try to shift one of the points until it's actually on the y-axis. I'm going to actually shift this whole graph 2.5 to the left. So shifting 2.5 to the left. Let's see here. How about if we leave myself a little space to write something down. Let's see here. 2.5 to the left. If I shift P 2.5 to the left, I'm over here at the point 0, 4.7. If I shift the 7.4, 1.2 to the left, I'm here at the point, let's make it a little bit lower, I think. How about 4.9, 1.2, and all we did was shift that exponential function, so I'm just going to draw something that looks like an exponential function. Looks like that. No. But nice if it was better than that, but here we go. Now, the idea is that's still too hard. So the second thing we do is we now compress. By how much? I want the 4.9. So what I'm going to do now is just compress the graph. Remember, the compressing doesn't affect anything that's on the y-axis. So that's going to look like that. But compressing by a factor of 4.9 will move this point exactly over to the point 1, 1.2, and it still looks like an exponential function. Goes down like this, goes up like this. When it doesn't actually matter what it looks like. I know it's an exponential function. Now, why did we do this? This is 1.2. We did this because it's absolutely trivial to write down an exponential function formula where the 2 points are 0 something, 1 something. And it's this easy. You write down this. This needs to be y-intercept. That's our A. And what's going to go in here is just going to be the ratio. We know the ratios are very important for exponential functions. So I'm going to get 1.2 here over 4.7 here to the x. We can also check our answer very quickly here, which is not something we can do if we do this algebraically. If I put in 0 for x here, I get 0 for the exponent here. Anything to the 0 is 1. 4.7 times 1 is 1, and so the top point checks. If I put a 1 in for x, the 4.7s cancel, and we get our 1.2. So once we make the problem easy enough so that I have 0 something, 1 something, writing down the equation is really easy, and it's really easy to check. Now, what do I need to do now? I need to work my way backwards. So what do I have to do to graph 2 to get to graph 1? I have to stretch out by a factor of 4.9. That's 4.9. That's a 4. Now, how do I do that? I write down y equals 4.7. The only place that has a check, remember this is a horizontal change, only the x's change, and I believe this is going to be x over 4.9. If your inclination is to put a times 4.9, let's just check. Now what do I want to do? I want to put a 0 in for x. When I put a 0 in for x here, I'm getting a 0 for the exponent. Anything to 0 is 1. 4.7 times 1 is 1, and the top point checks. What do I want to do on the bottom? I want to be able to plug in 4.9 and get 1.2. If I put a 4.9 on the top of that little fraction, I get 4.9 on the top, 4.9 on the bottom, that's 1. Anything to the 1 is just a thing, and then the 4.7 cancels, and I get this. So what did we do? We made the problem so easy it was trivial, and now we use our transformation knowledge and skills to work our way backwards. Now, what do we have to do to equation 1 here to get the original? We just have to shift everything to the right 2.5, and that's going to be putting an x minus 2.5 in wherever I see an x. So this is going to be y This is going to be 4.7. This is going to be 1.2 over 4.7. And in the exponent, I have to have, come on, I need a whole exponent here. There we go. I need x minus 2.5 all over 4.9. And even as complicated as that is, checking is now really, really quick, right? I want to be able to plug in 2.5 and get 4.7. When I put a 2.5 into that little fraction on top, I get 0 over 4.9, which is 0. Anything to the 0 is 1, and I get 4.7 times 1, I get 4.7. The check is almost automatic. When I put a 7.4 in, well, it's a little weird. 7.4 minus 2.5 is 4.9. Wahaha. 4.9 over 4.9 is 1. Anything to the 1 is the thing, and the 4.7's cancel. We get our 1.2, and we get our final equation here. And by the way, you can see from the equation where all the data comes from, which is, again, not something that happens algebraically. So this is something you can learn to do very quickly. It checks very quickly. The problem is that someone's going to ask us for rates of growth, and so we actually have to be able to rewrite this in terms of either b times a to the x or e times k to the x. So we'll practice that too. That's why that problem was actually in the Wiley plus thing, because they expected that you actually had seen this in algebra, which I'm thinking you didn't. So we're practicing that today, and then the next video will be about rewriting it so that we can find the rates of growth.